Consciousness, that elusive quality of being aware, of experiencing the world around us, remains one of the biggest mysteries in science and philosophy. It's the feeling of the sun's warmth on our skin, the taste of a ripe strawberry, the joy of a shared laugh. But what exactly is it and how does it arise? Defining consciousness is a challenge in itself. It's not simply being awake. It's about having subjective experiences, thoughts, and feelings. It's about knowing that we are aware, a concept captured in the phrase "I think, therefore I am" by philosopher René Descartes. Understanding how the brain, a complex network of billions of neurons, gives rise to this subjective experience is a daunting task. It's like trying to understand how a symphony orchestra, with all its individual instruments, can create a single, harmonious piece of music. Despite the challenges, scientists and philosophers continue to grapple with these fundamental questions. The quest to understand consciousness is a journey into the very essence of what it means to be human. Neuroscience, the study of the brain and nervous system, plays a crucial role in unraveling the mysteries of consciousness. Scientists use various techniques, particularly brain imaging methods like fMRI and EEG, to observe the brain in action and identify areas associated with conscious experience. Functional magnetic resonance imaging, or fMRI, measures brain activity by detecting changes in blood flow. When a brain region is active, it requires more oxygen, leading to increased blood flow to that area. fMRI can pinpoint these changes, revealing which brain regions are involved in specific tasks or experiences. Electroencephalography, or EEG, on the other hand, measures electrical activity in the brain using electrodes placed on the scalp. EEG is particularly useful for studying brain states like sleep and wakefulness, as well as for investigating the neural correlates of consciousness. These tools have provided valuable insights into the neural basis of consciousness. For instance, studies have shown that certain brain regions, like the prefrontal cortex and the thalamus, seem to be particularly important for conscious awareness. While these findings are significant, they represent only pieces of the puzzle. The challenge lies in understanding how these different brain regions work together, like instruments in an orchestra, to create the symphony of conscious experience. The global workspace theory, a prominent theory of consciousness, proposes that consciousness arises from the integrated activity of various brain regions, much like actors performing on a stage. Imagine the brain as a theater, with specialized areas processing different types of information. The stage in this model represents the global workspace, a network of interconnected neurons distributed throughout the brain. Sensory information, thoughts, and emotions compete for access to this global workspace. Only the most salient and relevant information reaches this stage of awareness. When information enters the global workspace, it becomes available to other brain regions, leading to a unified conscious experience. For example, when you see a red apple, different brain areas process its color, shape, and location. The global workspace theory suggests that this information is then integrated in the global workspace, creating a unified perception of the apple. This theory explains why we are only conscious of a small fraction of the information our brain processes at any given time. It's like a spotlight shining on a specific area of the stage, bringing it into focus while the rest remains in the shadows. While the global workspace theory provides a compelling framework, it's essential to remember that it's still a theory. The exact mechanisms by which information is integrated and selected for conscious awareness remain active areas of research. Section 4, Quantum Consciousness, a controversial intersection. At the intersection of quantum mechanics and consciousness lies a realm of intriguing, albeit controversial theories. Some physicists and neuroscientists speculate that quantum phenomena, like the superposition and entanglement of particles, might play a role in consciousness. One such theory, proposed by physicist Roger Penrose and anesthesiologist Stuart Hameroff, suggests that consciousness arises from quantum computations occurring within microtubules, tiny structures found within brain cells. They argue that these quantum processes could explain the non-computable aspects of consciousness, such as subjective experience and free will. Another idea, related to the observer effect in quantum mechanics, proposes that consciousness might be involved in collapsing the wave function, the probabilistic state of a quantum system before it's measured. This theory suggests that consciousness might play a fundamental role in shaping reality at the quantum level. However, these quantum theories of consciousness remain highly speculative and face significant criticism. Critics argue that the brain is too warm and wet an environment for delicate quantum processes to occur, and that there's no empirical evidence to support these claims. While the link between quantum mechanics and consciousness remains an open question, it sparks fascinating discussions about the nature of reality and the limits of our current scientific understanding. Section 5. Is reality an illusion? The simulation hypothesis. The nature of reality itself has captivated philosophers and scientists for centuries. Are we experiencing the world as it truly is, or is our perception merely a construct of our minds? The simulation hypothesis, a mind-bending proposition, suggests that our reality might be a sophisticated computer simulation. This idea, popularized in films like The Matrix, proposes that we might be living in a computer program designed by a more advanced civilization. Everything we experience, from the taste of chocolate to the feeling of love, would be nothing more than lines of code in this simulation. Proponents of this theory point to the rapid advancements in computer technology and the possibility of creating increasingly realistic simulations. They argue that if we can conceive of creating such simulations, it's plausible that we ourselves might be living in one. While the simulation hypothesis is impossible to prove or disprove definitively, it highlights the limitations of our perception and raises profound questions about the nature of reality. It challenges us to consider whether our experiences, however real they may seem, accurately reflect the true nature of the universe. Section 6. Altered states. Shifting perceptions of reality. Our everyday perception of reality can be altered in various ways, from dreams to drug-induced states. These altered states of consciousness provide fascinating glimpses into the flexibility of our perception and the brain's role in shaping our experience of the world. Dreams, for instance, offer a nightly journey into a realm where logic and reason often take a backseat to vivid imagery and fantastical scenarios. While we dream, our brains generate a world that feels real, albeit often bizarre and illogical. Meditation, another form of altered consciousness, involves focusing attention on a single point, such as the breath or a mantra. This practice can lead to a sense of peace, clarity, and a heightened awareness of the present moment. Psychoactive substances like LSD and psilocybin mushrooms can induce profound alterations in consciousness, often accompanied by hallucinations, distortions of time and space, and mystical experiences. These substances interact with neurotransmitters in the brain, altering its normal functioning and leading to these unusual perceptual shifts. Studying altered states of consciousness can provide valuable insights into the mechanisms underlying our everyday perception. By understanding how our perception can be altered, we can gain a deeper appreciation for the subjective nature of reality and the brain's role in constructing our experience of the world. Section 7. The Unending Quest: Consciousness, Reality, and the Future. The exploration of consciousness and reality is an ongoing journey, a quest that has captivated philosophers and scientists for centuries and will likely continue to intrigue us for generations to come. As we delve deeper into the mysteries of the brain and the universe, we uncover more questions than answers, pushing the boundaries of our understanding. Advancements in neuroscience, particularly in brain imaging techniques, promise to provide even more detailed views of the brain in action. By observing the neural correlates of conscious experience, we can gain a deeper understanding of how the brain gives rise to the subjective world we inhabit. Meanwhile, the rapid pace of technological innovation, particularly in fields like artificial intelligence and virtual reality, will continue to blur the lines between the real and the simulated, raising profound ethical and philosophical questions about the nature of consciousness and the future of our species. The quest to understand consciousness and reality is not merely an academic pursuit. It strikes at the very core of what it means to be human. It's a journey of self-discovery, an exploration of the inner and outer cosmos, and a testament to our insatiable curiosity about the world around us and the universe within.